We're putting cameras down to the seafloor. Every time we've put the camera down, it's been a different movie playing for us, in front of our eyes. The mission of this expedition is to study the Southern Newfoundland Slope area. It's an area that's largely underexplored, but that we know has a lot of really interesting and diverse types of habitat. I'm part of the science team, and my role has largely been handling the deep sea camera system.
Things like drop camera systems, things like environmental DNA, those are all techniques that we can gather information about the environment without damaging the organisms.
It's so important that we understand our oceans. They cover 70% of the world's surface, and the deep sea is the vast majority of that. So it's a bit rocky this morning. The wind is higher than it was yesterday, but we did just get the first drop camera in the water, and it was pretty smooth. So the camera is going to hover above the seafloor and touch every 30 seconds to make sure that we're getting on the seafloor. And it's going to be taking video of all of the species that live on the seafloor, corals, sea pens, fish species, crabs, all of that. When you're watching the video, you see the camera go through the water column. It's pitch black. You can't see anything for 10, 15, 20 minutes at a time. And then all of a sudden, you just see this blue-green landscape come into view out of the darkness. We've just come across sea pens as far as the eye can see. It's really kind of breathtaking to see that come into view.
Well, a lot of people don't know that we have cold water corals to begin with, right? We are used to the notion of corals in the tropics. A coral is an animal, and most people don't know that because they probably think that it's a rock or it's a plant. But in fact, they are animals. If you break, you cannot just begin to regrow. You might just die. They communicate and they cooperate. So there's channels between each single individual. So when you talk about a sea pen field, you have hundreds of colonies.
So sea pens are a type of soft coral. They kind of look like a feather quill, and they anchor themselves in soft sediments. And we found fields of those that range over 1 kilometer long. And then in some of the rockier, more bouldery habitats, we find corals like bamboo coral or bubblegum coral, which are these large, stiff, branching corals that can form forests almost. You think of a forest having birds and squirrels and stuff in those trees. These corals have shrimp and invertebrates and fish living in and amongst them, so it creates a 3D habitat for these fish in an otherwise kind of barren environment.
So right now we are in the dry lab space, and I am taking a look at some of the footage that we've collected on this trip so far. This is one of the sea pen fields that we found. As you can see, it is quite dense. In an image, you can have hundreds or sometimes thousands of small organisms that you have to identify, and that can take a really long time. And so I've started to use artificial intelligence to help with that, and basically I'm able to use a pre-trained model so that can cut down the annotation time by weeks.
As long as we have good weather, we're going to do as many drops and CTDs as possible. This is called a CTD, which stands for conductivity, temperature, and depth. These bottles will close shut at very specific depths, and it will trap water from those depths and bring it back up to the surface isolated. We filter those water samples and we collect eDNA from those. So we can tell what species have been in the area even if we don't capture them on the cameras.
Some of them can grow to hundreds of years in age. They can be very slow to grow, so they're slow growing, they are long-lived, and so it makes them a little bit vulnerable. They can be taller than us, they can live hundreds of years, and they're here in the backyard, and that you didn't know about it.
I think the biggest lesson from this trip is that you can make a plan and then the ocean will laugh at you. We're facing, on some days, 3-meter seas. We're trying to send cameras over 1 kilometer down to the bottom of the ocean. That's why it's taking a long time to pick away at little pieces of the ocean and understand more and more about these little pieces that we can access.
It's so much fun. We all kind of gather around the computer and are like, oh, what are we gonna see? What's going on? And then you come across the sea pen field and everyone's losing their minds. It's so exciting. The crowd on the vessel, we're all the first people who get to see this. And no one has ever looked at it before either. It's pretty special.
We want to know what is on the bottom of the ocean. We want to know what is their role. What are they doing there? What would happen if we don't have them?
You can't manage what you don't understand, and you can't protect what you don't know is there. And so this type of marine research is really important in collecting that critical data that we need to make data-driven, science-informed decisions on how we manage and protect our oceans.